So you probably can recall that when we talked about the classification of cost in terms of the behavior of cost, we are discussing about three types of cost: fixed cost, variable cost, and the mixed cost. So in the mixed cost, what we discussed that it is a such kind of cost where there is a mixture of both variable and the fixed cost elements. So we discussed about what can be the example of mixed cost, and we also solved some problems where we found that there is a application of mixed cost or there is a presence of mixed cost. So you can recall that we talked about the sales commission given to the sales manager, where there is a fixed portion of salary, and another portion of his salary is the variable, which comes from the per unit sales made by the salesperson. So one of the classic examples of the mixed cost is utility cost. From your utility bill you incur for your home, if you look at the bills, you will see, say in telephone bill, you will see the monthly line rent, and in electricity bill or power bill, you will see a fixed component, and in water bill also you will see a fixed component. So fixed component indicates that amount of bill or that amount of charge in your utility bill which you need to incur regardless of the usage of your utility or of your services. So say for example, you for 1 month you are planning to go outside of the country. So when you return to your home, you will see that your utility bill has come, and you will see the utility bill is not zero. Your utility bill is something, but your usage of the your usage of the units is zero. So regardless of the units, you still have to incur a fixed component or a component of bill. That portion is fixed, and over this fixed portion, there is another portion which go up and go down based on your usage. Okay, so that portion is variable. So if you use 500 units, or if you use 700 units, you will see that that for that portion, I mean the variable portion, the utility bill will change. Okay, so we see that in a single cost there is an application of both fixed and variable elements. And we also talked about some hospital, that what can be the example of fixed cost and what can be the example of variable cost in hospital. So you gave me some examples in that class, and if you want to recall that, I mentioned that the doctor's salary, then the nurse's salary, then the staff salary, these are some component which are fixed component. And but there are some variable costs, like the gloves, or like the gift pack given to the patients, or other supplies given to the patient. These are examples of variable cost. So if you think of the overall cost of a medical procedure, or overall cost of treatment, in that case you will see that overall cost of component has some fixed component and has some variable component. So this is the understanding of the mixed cost, which has both fixed cost and the variable cost. So we'll talk more about this graph. What you see there is a fixed component represented by the horizontal line, and this is the horizontal line which indicates the fixed component. This distance very specifically, and you see a linear line and positively sloped. Is it positively sloped or negatively sloped? This line, yeah, this is a positively sloped line, and you see that this indicates the variable cost portion, and we'll talk more about it, that how we can draw this, okay, and how, what are represented by this. And the mixed cost is taken care by accountants and engineers in different ways. The way that how we have defined the mixed cost in the previous discussion is a approach which is used by the accountants, and if there is a cost account, and what accountants immediately do, accountants immediately wanted to find out that this account is this cost account indicates some variable cost account or the fixed cost account. So if it is a kind of direct labor cost account, in that case, accountant will classify it as variable. And if it is a kind of factory rent, in that case, factory rent account will be regarded as the fixed cost component by the accountants. However, the approach of classifying cost or identifying cost by an industrial engineer is different. What he wants to look at, or she wants to look at the production methods, the material, labor, and the overhead requirement, and based on this, he or she classifies the cost. So it is an engineering approach. He's not interested whether the cost is variable or the cost is fixed. So in this part, we are more interested with the accountant analysis. And how can we analyze the mixed cost using a graph, which is more popularly known as a scatter plot graph? So we like to first identify that a cost is a mixed cost, or a cost is not a mixed cost. Other than the mixed cost, it is kind of purely variable or purely fixed. So we need to find out the behavior of the cost first using the scatter graph plot. Then if we are confirmed that that cost is a mixed cost, then we will use some approaches. One approach is HighLow Method. We like to use this approach to identify how much of this cost is fixed and how much of this cost is variable. Okay, so you have got the idea. Let's try to explore. Say we have been given an idea of the cost and some information of the cost, and we like to analyze it, that whether it is a mixed cost or it is not a mixed cost, rather it is a kind of fixed and variable separately. So you see that what does it indicate? It indicates the hours of maintenance and the total maintenance cost. So if we think for the 6 months, if you think of the Biman Bangladesh Airlines, they need to apply the maintenance on a regular basis. and they have a dedicated department for maintenance, and that department works for number of hours during this January month, during this February month, during this March month, for this number of for this number of hours. And for this number of hours, this maintenance costs are given to them, or this maintenance cost are overall incurred for the maintenance. Okay. So you see that if you think of a maintenance of a aircraft, uh, the mechanic or the technologist, or if you think of the engineer who will look after the maintenance issue, do you think they have a what is more likely, that they will have a fixed payroll or they will have a variable payroll? Which is more likely? The people who will work in the maintenance department, their salary, their salary is likely to be fixed. And what may be other components of fixed cost in the maintenance work? Say you have a space, you have a space in the runway where the maintenance work will be carried out. So you incur some cost for that space. Okay, simply think of cleaning the space. Okay, so what do you think? This kind of cost which will be required for that maintenance site will be likely to be fixed or variable? It is likely to be fixed. Okay, but you see, you will carry out maintenance of what? You will carry out maintenance of some aircraft. Okay, so when you will carry out works of maintenance works of aircraft, you need to install something, you need to discard something, and you need to replace some tires, you need to replace some parts, and you need to change the you need to change something, or you need to change some I mean, what I would say, that you need to change some lubricant oil, these things. So what do you think? This cost, what I mentioned in last few seconds, is likely to be fixed or is likely to be variable? Is likely to be variable. Okay. So when you are indicating that these are variable, you probably can recall that this should vary with some activity base. If activity base goes up, these are likely to be likely to go up, and if activity base go down, and this will likely to go down. Okay, so you see that you might wonder that instead of number of aircraft which we are maintaining, or on which we are carrying out our maintenance works, why we are using the hours of maintenance? Why we are using the hours of maintenance? What do you think? Is it likely that when you have a more hours of maintenance, it is likely that you are carrying out more maintenance works for the aircrafts? Or simply you are spending more hours without doing works? it is likely that you are looking after more aircrafts, more maintenance of more number of aircrafts when you are working for longer hours. Have you got the idea that when you have a longer maintenance hours, is it likely that you are carrying out maintenance works for few aircrafts, or you are carrying out maintenance hours for more aircrafts? Which is likely on a simple, you might argue, but which thing comes first in your mind? For more aircraft, you need more maintenance hours, you need more maintenance cost. So hence we can expect that the maintenance cost will go up and will go down when the hours of maintenance will go up or will go down. So which is indicating the activity base here? Which variable? Which variable here is indicating the activity base? Do not forget what we learned in the preliminary concepts. Hours of maintenance is likely to be the activity base here. Okay. So we have understood what kind of information is given to us, right? So we like to know that is it possible that we plot this relation between the hours of maintenance and the total maintenance cost, and we try to identify that whether this represents something look like mixed cost, or this represents something which are not mixed cost. Okay. So again, I like to recall that why we are doing this. We are wanting to plot a scatter graph to find out whether it is really a mixed cost. If it is really a mixed cost, then we will try to identify which portion is fixed and which portion is variable, right? Okay. So let's plot the relation. So which is likely to be the independent and which is likely to be the dependent? This is the learning from your statistics course, Statistics 101. Between the hours of maintenance and total maintenance cost, which is to be considered as dependent and which is to be considered as independent. Hours of maintenance is independent and the maintenance cost is dependent. Fine. Okay. From your economics 101, microeconomics, what you have learned that the independent variable or the variable which will run will be presented in horizontal axis or will be presented in vertical axis. What you have learned? The variable which will run or which is independent will be reflected in horizontal axis or will be reflected in vertical axis. Okay, the answer is horizontal. Okay, but some of you are saying that it is vertical, but I don't think so. So let's plot the independent variable in the horizontal axis. Independent variable is our activity base, which is hours of maintenance. Okay. So if we think of the first data, this one, January, hours of maintenance was 625 hours, and the total maintenance cost is 7,950. So let's find out what is the specific dot for this relation. Okay. So you see, in the horizontal axis, we are representing the hours of maintenance, which is our independent variable or the run variable. And in vertical axis, we are representing the total maintenance cost. Remember, it is indicating in dollar and it is indicating in hours. So 625 hours and $7,950 cost. Okay, 625. It is probably this one. No. Yeah, this one. You see that in this plot, we are probably representing something 625, right? 625. And we are representing something cost which are not, which is very closer to 8,000, like 7,950. So in this way, what can we do? We can plot each relation here. So you see, this plot, each plot here are scattered in the whole area. But we can find out some relation from here between the total maintenance cost and the hours of maintenance. So do you think it is possible to draw a straight line by connecting this dot like in this way? Or the dots are very far from the scatter plot? What do you think? The dots are very closer to the straight line what I have drawn, or the dots or the plots are very far from the very scattered from the straight line? Which things comes first in your mind? Not very far, very closer. Okay. So what is the understanding here? You probably can recall that when we use the linear term, when we believe that it is possible that we can draw a straight line between an activity and between an activity and a cost, we expect that there is a likelihood that there is a linear relationship between the activity and the cost. So as you have confirmed that it is possible that a straight line can be approximated, can be drawn by connecting these dots. In that case, we expect that there is and we believe that there is a linear relation between the hours of maintenance and the total maintenance cost. So you see that if it is not such a case, that if the let me draw an alternative scatter plot here. Say the dots are like this. What do you think? Say I try to connect at least these 3 dots. But what do you think? The other dots are closer to the straight line or much far from the straight line? Very far. In that case, you do not expect that there is a linear relation. So if you expect that there is a linear relation between the cost and the activity, in our case, it is the hours of maintenance. In that case, you should expect that it is likely that this cost has some indication of mixed cost. And there is another way you will see that you can draw a horizontal line here because the minimum starts from here. Minimum starts from here. Okay, this is another indication that this portion is fixed, and the excess portion which is going up is for the variable portion. So let's try to sum up that when it is possible that we can draw a linear relation. In that case, we can think of that it is likely that this cost is a mixed cost. In that case, our next task is to find out what is the fixed component and what is the variable component. So when you have confirmed that there is a linear relation, you probably can recall that linear relation is expressed by an equation like this. So it is more popularly known as a linear equation, by which we can represent this kind of linear relationship. Okay. So if we think of the equation here, we'll see that if we express the total maintenance cost as a dependent variable, that is y, and we represent the x as the independent variable, in our case, the hours of maintenance, and b here indicates the coefficient or the slope of this positively sloped line, which will indicate the variable cost per unit of activity. And there is a component here, what I indicated in previous slide, that it indicates some fixed regardless of the activity, you have to incur this. And that portion I mentioned that it is a fixed cost. And in the equation term, it is expressed as the intercept. Okay. So from this scatter plot, it is possible to draw this kind of graph, what we introduced in the first slide. Okay. So you see that this portion is fixed, and the portion above this, which is going up when the activity goes up, and it is going down when the activity go down, that portion is variable cost. Okay. So by summing up, actually the variable cost, if you want to find out precisely, it starts from here. So, if you want to see the variable cost separately, it should start from here. There is a pure relation, a pure linear relation between the variable cost, total variable cost, and the number of activity hours or the activity base. Okay, so when we sum up this this line and this line, we get this line, the total mixed cost. Okay, so now what we need to do, as we have confirmed that this is an indication that total mixed cost is a total maintenance cost is a mixed cost, we can go for next step to find out or to separating out the fixed component and the variable component. So before applying that, we like to use the equation what we have drawn here or what we have understood here for this case, like the utility charge, if your fixed monthly utility charge is $40, it indicates the intercept. Your variable cost is $0.03, which is B here, the coefficient or the slope per kilowatt hour, and your monthly activity level is 2000 kilowatt hours, which indicates the hour activity base by X. And what is the amount of your utility bill? The question is Y. So it is nothing. I do not like to underestimate your mathematical know-how, because you're much familiar with this kind of equation, that how can you find out the Y here, right? Okay. Now we like to separate out the fixed component and the variable component from a mixed cost, and how it is possible. So the first approach we like to use, that is the high-low method. Okay. So the same information has been presented in the left side. You see, the high-low method, what is our first task? Our first task is to find out which is the high point and which is the low point based on the level of activity. First of all, let me know from you that which is the high point based on the activity, and you mentioned the name. I mean the highest point. You mentioned the name of the month in your chat box. Which is the high point or highest point? Okay, June. So let's move to June. We see in June, the hours of maintenance is 850, which is highest among all of this. And if I ask you which one is the lowest point, what will be your answer? The answer is February. Okay, this is the lowest point. Okay, so you have find out the highest 850 and lowest 450. Now you have to find out what is the corresponding cost, the total cost. Here we have the total maintenance cost, corresponding total cost with respect to this highest activity base and with respect to this lowest activity base. So we see for 850 activity base, we have 9,800 here, 9,800. And for the lowest activity base of 450, we have this 7,400 cost here. Now our task is to use this filtered information. I have mentioned the filtered because you have filtered 2 points, high and low point, based on the level of activity. Now you have filtered out, and you need to use this information to find out the variable cost per hour. So here we are representing variable cost or defining variable cost in this way, which indicates the ratio between change in cost divided by change in hours. So actually this is the technical definition of the variable cost. This is not a conceptual definition, but this is a kind of technical definition. So change in total cost and change in what I would say here, change in hours or change in activity base. Okay. So you see that between the high and low point, what I would say about the changes in the total cost from the 9,800 to 7,400, what is the change here? What is the change of the total cost here? I lost my pointer. Okay, fine. Okay. You have responded in the chat box. The changes in the total cost is 2,400. So let me write here 2,400. Now, what is the changes in the activity base for this high and low point? The 400. 400. Okay. So if you divide, if you express the ratio in the single number, you will get $6. So as you're dividing this by the hours, you can mention that this $6 is per hour. $6 is per hour. What do you think? This indicates what? This indicates the variable cost per hour, which we have learned a few minutes ago in the technical definition. Okay. So you have found a variable cost per unit or the slope B. You have the X. You do not have the A, but you know that what is Y, the total. Is it possible to find out the A or the fixed cost component? It is much straightforward. So let's do this first. Then we'll see that. Okay. So any point you can use, either high or low or anyone among these. Yeah, anyone between high and low, as long as you have used these two values. Okay. So let's use the high point, the 9,800. Then we do not know A. We know that B is equal to 6, X equal to 850. So what should be the fixed cost? What do you think? Find out. $4,700. So what you have got? You have got A is equal to 4,700. From this, what you have measured? 6 multiplied by 850. 6 multiplied by 850. What you have measured in this portion? The total variable cost. So what is that amount? The BX. 5,100. So this is the way that how can we capitalize the high and low values from the information to find out the fixed and to find out the variable. Okay. Okay. So let's see that we have solved it properly. So you have solved it properly. The total fixed cost you estimated is 4,700. Okay. So can we write this equation as we have solved the A and B? Can we write the cost equation, I mean for the mixed cost, in this way? Okay. Now, if I ask you if the hours of maintenance is 1,000, what will be the total maintenance cost? 1,000. What will be the total maintenance cost? If the hours of maintenance is 1,000, what will be the total maintenance cost? It is out of the relevant range. Okay. So why do you think it is out of the relevant range? Do you have the information that what is the relevant range from the data we have mentioned here? Do we have the information about the relevant range? We have only the data for 6 months. High is 850, but we do not have all the data. It is possible to claim that it is reasonable to approximate that 450 to 850 is the relevant range for this fixed cost what we estimated. So as long as this is 1000, and we can claim that it is out of our activity range, and if we use the 1000, our fixed cost will no longer be 4700. We can claim it based on our high and low point. So there are some quick check. So look at it and give me your answer in the chat box. What is the variable portion of sales, salaries, and commission? Sales, salaries, and commission are 10,000 when 80,000 units are sold, and 14,000 when 120,000 units are sold. Using the high-low method, what is the variable portion of sales, salaries, and commission in terms of per unit? So it is asking for the B. Very quick. We are getting the answer 0.1 or answer B. So let's ask the computer what is the right answer. We see the right answer is this one. The calculation is straightforward. And from the same information, probably said that, yeah, same information. What is the fixed portion of the sales, salaries, and commission? From any point between high and low, you can estimate it. Very straightforward. 0.1 multiplied by, if I take the high point, 120,000. In that case, it will be 12,000. And if we subtract the 12,000 from the 14,000 total cost, it will be 2,000. So I see that you have solved it correctly. It is 2,000, right? Okay, I assume that you have understood it. Okay, let's use the second approach. You have confirmed that it is a scatter graph, that it is acting like a mixed cost. We now use the second approach to find out the fixed and the variable component, because there are some constraint with the high and low value method, and we'll talk about it later when we'll complete it. Least square method. Have you heard about this term, least squares regression, in your applied statistics course or the basic business statistics course? Have you come to learn about it? Okay. Can you give me the idea why it is set, the least square? What is the actual idea of this term, least squares regression? In your own language, what do you have meant by the least squares regression? Yeah, perfect. Perfect. The regression which we get the square deviation as minimum as possible. Okay, it is our target. Okay, so the constraint of the high value and low value method is that you probably can recall out of the 6 data point, we have used only 2. For that constraint, and for overcoming that constraint, in this approach, we use all data point. I mean, we'll use the all 6 data points to get the fixed and variable cost. Okay. And the answer to the question what I asked from you is here. to minimize the sum of the squared error, and minimize is indicating the least, and the sum of the squared error has been shortened as square, but actually it is sum of the squared error. So if I want to make you recall that which portion is it is indicating, it is the portion which you measure here, say xi minus x bar, this is the average, and you make a summation. This is the error term. This is the error term which you have measured it by. It is the actual that you see that this is the actual data, and this one, if I write the sign in this way, you have measured based on your regression, and you measure this, and you get the squared error, and you want to minimize this in total. Okay, that's why it is this portion. Okay, so let's proceed. That how can we use this? You have learned that how can you use this in your calculator manually, but we commonly use the Excel to find out the intercept, to find out the slope by capitalizing this data. And the thing is that when we write the equations are long, and we often try to avoid this for avoiding error. But so you can use either Excel or you can use the manual approach to find out the fixed cost component and the variable cost per unit using the least square regression method. So when you use the least square regression method, there are number of test statistics, but one statistic which is critical, that is the R square, which indicates the goodness of fit. Goodness of fit. Can you recall the scatter plot? That based on the regression equation, you can draw an equation, right? So when R square is a big number, what you expect? The dots will be much closer. The dots indicates the actual relation. So in the regression, the dot expresses the relation between the actual one and the expected one. So based on the regression, you measured some expected and you have the actual data. So if you plot a scatter graph using expected and the actual, and if you see that it is possible to draw a very precise straight line, is positively sloped line or negatively sloped line. It depends that what is the sign of here. Here we are expecting it is positive. That's why I have drawn a positive line. So the goodness of fit indicates that as long as the R square is a good number, this relation will be very strong, and the dots will be very closer to that line. And in conceptual term, it indicates that the total variation of the y, explained by the total variation of the changes in x. Okay. So we have reviewed that what we have learned by R square, and this is here. We like to use the information, and when we have used the information in Excel or use your formula, what you learned in statistics, you will see that the slope is here 6.02. You probably can recall in the high-low value, we found it is 6, and the fixed component is here $4,395.67. Can you recall that what we have found in the high and low value method? Uh, 4,700. So you see that these are different. I mean, the value what you estimated using the least square regression method. Now, this is the application of R square from applying the Excel or applying the formula. It is possible to find out the R square value. So you have learned how to interpret the R square, and when it is above 90%, it is a kind of excellent explanatory power. So you find that out of the total mixed cost variation, out of the 100% variation of the total mixed cost, 92% variation of the total maintenance cost, or here our mixed cost, is explained by the variation in the maintenance cost. Variation in the maintenance cost. It is actually the 92% of the variation in maintenance cost is explained by the variation in maintenance cost. There is probably some missing here. What do you think? What will be the fill in the gap? How can you fill the blank? The variation in the variable cost, right? What do you think? Or you'd say here variation in the, what is our X here? Yeah, there is no blank. You see that it is our X, the maintenance hour. Okay. So we can compare the results from two approaches, and we see that there is a differing amounts. And if you ask that which one is more accurate, the answer is the least square regression is more accurate, and we need to use that. Okay, so we like to apply what we have learned by solving an exercise in the Excel, and you have asked question that how can we measure the slope manually? The answer is you go back to your learning of the regression class and look at what is the equation we use for measuring the slope manually and measuring the intercept manually. Then you can find out that what is the manual approach. And we'll not show it in this class because we'll use the Excel output for our understanding. Here in this class, our task is to find out the way that how can we use our Excel and how can we interpret it and how can we calculate it manually. That is the objective in the statistics class. Okay, so let's take you to an exercise, and I again like to highlight that get accommodated with using Excel and solve your exercises both in your script and also in your Excel to make your learning more solid. Okay, so out of the exercises, we like to talk about the least square regression exercise in the exercise 5A5. Remember the contents what we covered is in the appendix of chapter 5. So that is actually from 5A. So this exercise 5A5 is based on the learning of the appendix. Okay. Okay. So let's look at and try to find out. Let's read together, or you read yourself, and I will start reading by couple of seconds. Okay. So Solin and Suez, located in Toulouse, France, makes high-tech stopwatches in small batches. The company has observed electricity cost in the table at the right over the last 6 weeks. For planning purpose, management would like to know the amount of variable electricity cost per unit and the total fixed electricity cost per week. Okay. So they are variable, they want to know this. Prepare a scatter plot graph, place electricity cost on the vertical axis and the units on the horizontal axis. All right. This is our number one requirement. Okay. So here the electricity cost which have been given here is a monthly basis or weekly basis or unit basis. What do you think? It is mentioned somewhere, but I'm asking from you. On a weekly basis, it is given. Okay. So for preparing a scatter plot graph, you can do it manually. And let's try to use the Excel. Take this data from here. Okay. So I'm showing you how can we solve the problem in Excel, and the data are here. Let me make it visible. Okay. Now our task is to find out the scatter plot. This is our first requirement. So from the insert, you have a chart. These are some scatter plot indication. We use a simple one. So we need to now select data. By clicking it, you will get the data, then select data. So our dependent variable should be here. Our dependent variable name is, we are here, the electricity cost, it is our name, and the X values. Okay. X values here, our independent variable is the number of units of the stopwatch or smartwatch. I can't recall right now. Okay, Y values are electricity cost here. Okay. So let me stop here. Okay. So I'm not giving the title or editing this, but what do you think? Is it possible to draw a straight line using the dots? And if I draw a straight line, that will be closer or that will be far from the straight line. That will be closer. Okay. So it is possible that you get other. Okay, let me use this. If you draw a trend line, what is our expectation? Okay, I want to draw a linear trend line. Okay, linear trend line. So our linear trend line is here. Okay, And if we make a linear forecast line, what will be available? Okay. Okay, let me write the linear trend line here. And okay, we have drawn a linear trend line. We see that our expectation is true, that if we draw a straight line, that will be closer to our the plots will be very closer to our straight line. Do you have any question up to this on the scatter plot? Okay, no question. Second one, okay, you can place the electricity cost on the vertical axis and the units on the horizontal axis. We have done this exactly. And now what is our second task? Using the least square regression method, estimate the variable and the fixed elements of the electricity cost. Express this estimate in the form y equals to a plus bx. Okay. So let's keep it separate. Here is our y and x, and we like to use the regression techniques. And how can we find out? Okay. If you go to data, there is a data analysis tab, and I'm confident that you have learned it, that how can you make it visible if it is not visible here. You have learned it from your statistics. If you do not know, you can ask me that if it is not available, how can I find out it? Okay. Obviously, your friends will also be helpful. Okay. So in the data analysis, we find the regression. Here I have clicked OK. And what should be our Y range? Our Y range should be the electricity cost. It is our Y. And our X will be the units here. And you see, when I have selected the first cell of each column indicates some levels. Otherwise, there will be some error messaging. Okay. And that's why I have checked it, because the first cell indicates the level. Now you can select the output range where you like to get it, or by default it is new worksheet. In new worksheet, you will find it. Okay. Now we do not want to get other things. You can also find the line fit plots to get how to express the goodness of fit in the graph format. So it is kind of optional things. Okay. Now I'm clicking OK. Let's see that it is possible. Okay, let's find out. This is our regression output. So what I'm doing, I'm changing it to auto fit. And what I'm getting here, I'm getting that. Okay, what is our requirement? So let's look at our requirement, then we'll come again. Estimate, we have already solved our least square regression and we have our output available. We need to find out what is the variable element of the electricity cost and the fixed element of the electricity cost. So we see that fixed element is 140.19. What do you think? Fixed element is 140.19. Is it? This is our fixed element. This is not something new. This is our fixed element. I'm highlighting it. Or okay, here. This is our fixed element. The intercept is equal to 140.20. if we express in 2-digit decimal. Okay. And what is our variable cost per unit from the output? Is it here? Variable cost per unit in anywhere? 5.08. So 5.08 is here. This is our variable cost per unit. So this is here. We have got it. Our variable cost per unit is 5.08. Okay. So express this estimate in the form of y is equal to a plus bx. Now, how is it possible? So if we are here, what can we do? We can write out the expected electricity cost is equal to y is equal to, you have mentioned that fixed cost is equal to 140 something. Okay, 140 something. I'm not closing the screen. Okay. Okay. You can write in this way 140.20 plus the variable cost or y, sorry, b, you have measured 5 point something, 5.08. And here you need to write the x. So this is the equation that has been asked in the question, right? Where we are. Yeah. So you have found this one. Now, if the number 3 requirement, if the company processes 145 units next week, what would be the expected total electricity cost? So what will we do? Okay, what will we do? We will look at the 145 units and we'll replace the x by 145 and we'll get the answer for number 3. So what will be the answer for requirement 3? If you solve it, you will see that it is something over 800 or 876 or 800. Okay, so this is the way that how can we attack this kind of problem. Okay, so this is the requirement 1. They have used the earlier version of the Microsoft Excel. That's why you see some old looking windows. Okay, so you can find out this trend line in this way, and what we measured using the regression, it is also possible to write it on the trend line. And this is the requirement 2. We have shown it. How can we write it? And the requirement 3 is 876.8. So let me stop here.